Okay, here's a quick overview on how to sketch a graph of this function. For this rule and this rule, we have two straight lines. But the easiest way to sketch them as part of a piecewise function is to figure out what the points are at the endpoints of the interval. So here's a little table for the first rule. All right, it is negative x plus 3. When x is 0, that's the left-hand endpoint. Y is 3. When x is 4, even though 4 is not part of this rule, that's an endpoint that we're going to approach. So when x is 4, y is negative 1, but when you graph it, you have to think of that as an open circle. 4 is not in the domain for this rule. Over here, 4x minus 16, when x is 4, y is 0. When x is 9, y is 20. So for this rule, it's a line with a slope of negative 1. That looks right. The y-intercept of 3. That looks right. But we've got an open circle here. For this rule, 4, 0, that's a closed circle. 9, 20 kind of went off the chart here. It's up here somewhere. And that's where the absolute max occurs. When x is 9, y is 20. But for the absolute min, you have to understand that an absolute min must be an exact real number. It turns out this function is bounded by y equals negative 1. You can't get below negative 1, but you can't get there either. So we say there is no absolute min. Here's an example. If I ask what's f of 3.9999, I get real close to negative 1. And I could keep adding 9s here. And I get closer and closer to negative 1, but I'd never get there. So we don't have an exact absolute min. There you go. Hope that helped. If you have any questions, post a comment.